Hello, my fellow historical geology students. My name is Christina Manisel, and my presentation is over meteorites and impacts in the state of Arizona. I first became interested in this topic when my physical geology class visited the Museum of Natural History in Mesa last fall. Housed in the museum is a replica of a meteorite that was discovered in Tucson, so I'm going to start there. Pictured here is the Tucson Ring and the Carlton Mass. The Tucson Ring in the background is 1,400 pounds, where the Carlton Mass towards the front is 630 pounds. Not much is known about the origin of these meteorites, but the first written account comes from a pioneer by the name of Velasco in 1845, where he saw these rings being used at the Presidio, and when asked about it, he was told that they were found in the Sierra de la Madre, which is known as the Santa Rita Mountains today, in an area, a passage called the Puerto de los Muchachos, which is known as Box Canyon today. At least that's what people think. It is said that in this canyon there was something called the Iron Valley, where there were many pieces of large iron masses that had rolled to the bottom, and these two medium-sized pieces had been pulled out and dragged over 30 miles to the Tucson Presidio, where they were being used as a workbench and an anvil for blacksmiths. A scientist saw these in 1850 and recognized them as meteorites. This happened to coincide at the same time that control of the area was transferring from the Mexican government to the American government. And a man by the name of Irwin was sent by the government to claim the Tucson Ring, which he did, and send it to the Smithsonian Museum. The Tucson Ring arrived at the Smithsonian in 1864. The Carlton Mass, on the other hand, was still being used as an anvil in a blacksmith shop, until the late 1860s, when a general, whose last name happened to be Carlton, confiscated it and sent it to a museum in San Francisco, where it remained until the 1900s, until it was eventually sent to the Smithsonian and housed with the Tucson Ring. The Tucson Ring has a very unusual composition. It is 92% iron and 8% silica, which is very rare for meteorites, and also very valuable. In 2010, a 4.7 gram piece of the Tucson Ring sold for $2,390. Doing the math, that means the Tucson Ring itself would be valued at over $320 million. It's no wonder why people still spend much time in the Santa Rita Mountains looking for the Iron Valley. Other famous meteorites from the state of Arizona include the Navajo, which was discovered in 1921. It's two separate meteorites, one weighing 3,300 pounds and another one weighing 1,500 pounds. And then the Winona meteorite, which was discovered in 1928, weighs merely 53 pounds. However, these meteorites were not discovered by meteorite hunters or geologists. They were discovered by archaeologists who were excavating ancient burial sites and Indian villages. These were found in elaborate burial chambers, wrapped in linens and placed with fine offerings that you would normally only see for royal burials or leader burials. The cultural significance of these burials is yet to be determined. However, many meteorites have been found in burial chambers in northern Mexico, so there's more to come on this, I'm sure. There are many famous strewn fields in the state of Arizona. This map here indicates strewn fields that are known in the state, and this map up here indicates a strewn field from a meteorite that blazed over the Prescott skies on February 16, 2020. The largest pieces can be found in the red area, and it would go out to the smaller pieces in the yellow. A strewn field, of course, is a field of debris from a single fall, as the meteorite breaks up in the atmosphere. Not only can you find the small pieces of meteorite in this area, you can find tektites, which is usually gravel-sized glassy objects that form from the molten debris as it breaks up in the atmosphere. There are several famous strewn fields. The Gold Basin strewn field was discovered in 1995. Many of the samples that have been brought out of that field have been analyzed by the University of Arizona that have dated the samples from 14 to 17,000 years ago. The strewn field is extremely large as it covers 200 square miles. Originally, it was believed that it is the strewn field from one meteorite, but through the University of Arizona's research, not only from composition, but from the weathering of the meteorites, they've discovered that this is a strewn field that has over 12 different meteorites in it. Another famous strewn field is the Franconia. The Franconia has been heavily investigated by Arizona State University, where they have also discovered multiple strewn fields that range from 20,000 to 7,000 years ago. Holbrook, Arizona is one of the strewn fields of recent history. This strewn field occurred from a meteorite breaking up over the town of Holbrook on July 19th, 1912 at exactly 7:15 p.m. We are lucky enough that we have a lot of eyewitness accounts that were taken at the time of the event. The largest piece found was 14.5 pounds, and the smallest pieces were, of course, the size of gravel. But over 15,000 meteorite pieces have been recovered from the Holbrook strewn field, making it one of the most well-documented strewn fields in modern history. Just outside of Holbrook is, of course, the most famous impact site in Arizona, the Meteor Crater. The Meteor Crater has a fascinating history to it. In 1891, a scientist by the name of Albert Foote was the first to actually suggest that this was an impact crater from a meteorite because of the evidence he gathered around the rim, which included small pieces of meteorite. So the United States government subsequently sent out a scientist by the name of Gilbert, who decided that since this crater is just a mere 40 miles away from the San Francisco Peaks, a known volcanic area, that this was not a meteorite crater, it was a volcanic crater because there was no evidence of a large meteorite at the center of the crater. Not everybody agreed with Gilbert's conclusions. One of them was Daniel Barringer. Daniel Barringer was not a scientist, he was a businessman, and he happened to own the Standard Iron Company. He was convinced that this was indeed an impact crater, and at the center of the impact crater, just buried deep below sight, would be the remnants of the mass that impacted. He suspected that that mass would be 100 million tons, and in 1903, 100 million tons of iron ore would equate to over $1 billion. So he convinced his friend, Teddy Roosevelt, to give him claim to this land. Barringer spent over 27 years drilling and mining the center of the crater to find this mass that he truly believed was buried, and also to prove that it was not a volcanic crater, but indeed an impact crater. Unfortunately for Barringer, he never did find that mass, but in 1960, a scientist by the name of Shoemaker, who was investigating the site, found rare forms of silica from quartz that had been shocked on impact, finally proving once and for all that this was indeed an impact crater and not a volcanic crater. It was the first impact crater to be recognized in the world, so it was a pretty big deal. The mass itself that made this crater would have been 160 feet in diameter. The impact crater itself is a mile wide. It's 560 feet deep now, but It's believed at the time of impact it was much deeper, as the climate for the area was much wetter. It would have become a lake, so there is well over 100 feet of lake sediment currently at the bottom of the crater. They say 175 million tons would have been dispersed upon impact, and the impact itself would have been 10 megatons. Just to put it in perspective, if you took every explosive that was used in World War II, including the Hiroshima and Nagasaki bombs, that's only 3.5 megatons. This caused a 10 megaton explosion. It would have killed everything within miles of the impact. They estimate that it would have taken well over 100 years for this area to recover from the impact. Where it didn't kill the dinosaurs, it certainly made a big effect here. A piece of this meteorite from the Barringer crater recently sold at auction. This piece weighed 70 pounds, and at auction it set a record, and it sold for $237,500. So I guess there is money to be made in meteorites after all. I hope you've enjoyed my presentation. Thank you.